Hi, it's Mrs. Pope, and today we're going to talk about solving polynomial equations. Our goal is to use the sum and difference of perfect cube formulas, which I have here, which you will need to memorize, and we're also going to factor by grouping. So, the sum and difference of perfect cubes, these are the two formulas that you will be responsible for memorizing. You will not be given these on quizzes or tests. You must memorize them. They're not that bad, though. So let's see when we would use them. So factoring, we have difference of perfect squares we've done. Now we have something called the sum and difference of cubes. So if you have a perfect cube plus another perfect cube, you factor it such as this. A plus b times a squared minus ab plus b squared. If you have the difference of perfect cubes, then it's a minus b, a squared plus ab plus b squared. So let's look and see what that means. First, example 1, let's factor 8x cubed plus 64. Remember, whenever you're factoring, it does not matter what type of factoring. You always want to look for the GCF and see if you can pull something out. And I notice here I can pull an 8 out, and this will save me down the road. So if I take an 8 out here, I would be left with x cubed plus 8. Now I have an 8 outside, a perfect cube, plus another perfect cube. And so my a here would be the cube root of x cubed, which is x, and my b is 2. So I have a cubed plus b cubed, x cubed plus 2 cubed. And we just keep this 8 out here the whole time. So now let's follow what it says we should do. Well, it says we should take a plus b, so x plus 2 times x squared minus ab, or ba, plus b squared, 2 squared, which would be 4. And don't forget, we have to keep the 8 on the outside. That's all we really have to do, is plug it in, and don't forget, if you factor out a GCF, you need to add it back into your final answer. All right, let's look at the next example. Example 2, 16x to the 4th minus 54x cubed. Look at the GCF. Is there a GCF? Yes, there is. I can take out 2x. If I pull out 2x, then I'm left with 8x cubed minus 27y cubed, because I divided the 2x out of each term. Now, if you look on the inside, I'm left with a difference of perfect cubes. And from our formula earlier, we know the difference of perfect cubes. Let's look at what a is going to be. A is going to be the cube root of the first term, so 2x, and b is going to be the cube root of the second term, which is going to be 3y, and we're going to use those in our formula. So you should have, this is the difference, so let's see, we want 2x minus 3y, let's see if I have it memorized, times a squared, 2x squared, plus, multiply these together, so 6xy plus 3y squared, which would be 9y squared. I simplified that already. I showed you what I was doing here. So don't forget our 2x was our GCF, and then we have 2x minus 3y times 4x squared, I squared that, plus 6xy plus 9y squared. And that should be our final answer. It's all factored in factored form. All right, now let's look at something called factored by grouping. This is something you use when you have more than 3 or 4 terms. So when you have, let's just say, many terms. So if you have a bunch of terms here, you can group them together, pick out something they have in common, and factor from there. So let's see how it works. Here we have 8ax plus 4bx plus 4cx. Notice all of these have x. 6ay plus 3by plus 3cy, they all have y. So we've put them, these are already put together, and we're going to see what happens if we factor out what's in common. So here I can factor out a 4, and I can factor out an x. So if I factor out 4x, what would I be left with? 2a plus b, right, plus c. 2a plus b plus c. Now let's factor out here. What can I factor out here? I can factor out a 3, and then I'd be left with, oh wait, I can factor out 3y, and I'd be left with 2a plus b plus c. And the way I know I factored them correctly, look, they match. If you get something that matches on the inside, then that is one of the factors, 2a plus b plus c. And the other factor is what I like to call Thanksgiving leftovers. It's whatever left over, what you factored out. Put them together as one. So we would have 4x plus 3y. And now this has been factored by grouping. One more example today. Factor by grouping, move around. This is the commutative property. The last one was set up really nice for you. It was already in its little factored form. So let's look at what we have here. We have y's, z's, that has a y, that has a z, that has a y, that has a z. And then the g and the h, none of them have all of them in common. So what I'm going to do is pull together the y's and pull together the z's. So this has a y, this has a y, this has a y. Let's put those together. So 20fy plus 15gy minus 10hy. So I've put those together. Plus, let's put together the other ones. Where are they? Let's put the z's together. So this has z, z, z. So it's going to be plus, where's all my z's? Negative 16fz plus 8hz minus 12gz. So now I've grouped them so I can factor them separately. I've grouped this one together and this one together. I'm going to factor them separately. So see what you have in common here. We should be able to pull out a 5 and a y. And then what will be left? 4f plus 3g minus 2h. So I factored out the 5y. And then here, we want to factor out, careful, you want to keep the sign here. So I'm going to factor out a negative 4z. If I do that, you'll see that I'll end up with 4f plus 3g minus 2, let's see, something, that's not the same. What should I be factoring out? 4z, yep, that's right. This should be 3. I wrote that wrong. Hang on. Erase, erase. Let's see what we took out. I took out a 4z. So here that would give me 4f, right? And then minus 2h, because the negative 4 times minus 2 would give me 8. And the h is missing. And then the minus 4, I would multiply by the 3g. There, that looks a little bit better. So we have 4f minus 2h plus 3g over here. And here we have 4f plus 3g minus 2h. They look like they're different, but they're just in different order. Notice the negative is with the 2h, the 3g is positive, the 4f is positive. So they are indeed the same term. So my final answer, one of those, 4f plus 3g minus 2h, and the Thanksgiving leftovers, 5y minus 4z. So that will be in factored form. Thanks for watching, and remember, you are responsible for your own learning.